This video will look at the condenser fan and the condenser fan switch and operation. And then we'll get into some troubleshooting at the end. The condenser fan on the highway trucks also doubles as our engine fan. And the condenser fan operation really is critical, especially when the truck is parked. You have to have airflow through the condenser in order for that air conditioning system to work properly. And when we are parked or sitting at a loading dock with the AC running, the only means of getting airflow through the condenser is the fan. There are lots of variations of wiring out there. I'm going to just give you a list of some of the possibilities, but at the end of the day, you really are going to need some OEM information if you run into a wiring problem. Once again, we go back to the very basics. Let's start at the inlet of the orifice. For this video, I don't really care if it's a CCOT or a TXV system. It doesn't matter if it's a house air conditioner or your refrigerator. The concept is the same. So we'll start at the inlet of the orifice with a high pressure liquid. We drop the pressure on that liquid through the orifice, run that refrigerant through the evaporator and allow it to absorb heat, send it off to the compressor, through the compressor, send it through the condenser to get rid of its heat, and back to the orifice to repeat the cycle all day long. Our condenser fan switches can take many forms. To start with, I wanted to show you some pretty common stuff out there on the trucks. Expect to find something that looks like this. These switches actually sense pressure. Okay? They are not a direct temperature sensing switch. They sense pressure. How can this possibly work? Well, if we remember back to the fundamentals, there is that relationship over here between pressure and temperature and pressure. If the temperature of the refrigerant goes up, so does its pressure. So these switches assume temperature based on a pressure reading. Now down here is a slightly different version. You typically won't see these a lot on the trucks. This will be something more like your household air conditioning system, but they are out there. These particular switches will clamp directly to the metal portion of an AC line, and they sense temperature directly and therefore assume pressure. Along with the different varieties of condenser fan switch that I showed you in the last picture, they also come in a normally open switch that will close at pressure, or a normally closed switch that will open at pressure. Don't assume just because two switches look physically the same that they operate the same. You got to make sure you're putting on the right part number. One thing that is common, regardless of style of switch, physical appearance, normally open or normally closed, is you will always see the condenser fan switch on the high side of the system, not on the low side. And these switches are typically going to actuate our condenser fan somewhere around the 250 to 300 psi mark. Now that said, there's a wide variety of pressure ranges on these switches. 250 to 300 is a pretty safe generic spec, at which point we want our condenser fan to come on. Let's just have a quick look at some options for engine condenser fans and for wiring. This is going to be really generic stuff. I can give you what's most common, but again, if it comes into any serious troubleshooting, you're going to need some OEM information. To start with, the most common configuration out there as far as what an engine condenser fan is a spring-applied, air-released fan hub that is driven by the engine. Typically belt driven, but there are some gear driven variations out there as well. You can have an electrical fan hub, straight out 12 volts applied to make it engage fully and 0 volts to make it disengage. Basically, we use electricity instead of air, but it's still either on or off. There are some electronically controlled fan hubs out there where a module, or a lot of times an engine ECM, will send out a pulse width modulated signal, and that gives us a variable engagement fan. Thermatic fans are out there, also called the viscous drive. Now those are the ones that are always partially engaged, and as the little sensing bulb on the front of the fan hub heats up, it engages more. Not very common. Typically, again, older vintage trucks, they had an air applied spring release fan hub. The spring apply air release is much more common now because of the fail safe. If something goes wrong with the circuit, you want your condenser fan and engine fan to be running full time, as opposed to just not having it come on. What are some wiring options? Well, there's a lot of them. I'm just going to talk about 4 generic ideas, but again, if you get into any major wiring problems, you're going to need some OEM information. Very, very common on the highway trucks is the condenser fan switch will signal the engine ECM directly to turn on the fan for air conditioning demand. Also out there, condenser fan switch will signal a chassis ECM of some sort, and the chassis ECM can either directly control the fan hub, or the chassis ECM can tell the engine ECM that it's time to turn that fan on. You could have something a little bit simpler. The condenser fan switch directly controls a relay. The relay controls a solenoid or sends power directly to an electric fan hub. You can also have the condenser fan switch directly controlling an air solenoid that sends air to the fan hub. So lots of options out there. You need to know which one you're dealing with. Let's get into the troubleshooting end of things. What happens? Well, what if there's a problem with the condenser fan or the circuit that controls the condenser fan, and we can't get it to come on? What would we expect? Keep in mind now that heat and pressure go up together and they go down together. With the truck parked, more especially is where you're going to notice this. If that condenser fan is not working, your high side pressure is going to skyrocket. It will be much, much higher than normal. Why? Back to the fundamentals. If you're picking up heat in the cab, you have to get rid of it outside the cab. With the truck parked, the only means of getting rid of that heat is airflow through the condenser. So if the fan isn't working, you're not going to get rid of that heat. You collect heat in the cab, you keep it in the system because the fan's not working, the pressure on the high side will skyrocket. You'll also see your low side pressure come up a little bit higher than normal, but at the end of the day, the most noticeable thing is that high side pressure will spike instantly. Along with that, you're going to get poor cooling in the cab. Again, if I can't get rid of the heat outside of the cab, and I just continue to pick up more heat and I can't get rid of it, I can't have my air conditioning system work properly. Also, likely going to get a complaint of the engine overheating when the truck is parked. What if the condenser fan is working, but there's a problem with airflow through the condenser? Now this happens quite a bit too, and at the end of this slide I'm going to show you exactly what happens. What it comes down to is an external blockage. Now, expect to see whether that truck is parked or whether it's moving. Again, high side pressure, much higher than normal, poor cooling. The difference is now the condenser fan is going to run all the time. The condenser fan is trying to cool down the refrigerant and it's trying to keep the engine from overheating, but because we've got a problem with airflow through the condenser and through the charge air cooler and the radiator, that fan cannot do its job. Where do things go wrong? Where you need to look is right here. You need to climb up on top of that truck, get down there with a flashlight, and have a look between the charge air cooler and the radiator. It's a notorious spot for debris building up, whether it's in Alberta, we get poplar fuzz in the springtime, could be road salt and sand from the winter, could be dust, could be anything. But it's very, very common to have a debris buildup in that area and very difficult to see unless you get up on the top and have a look directly down. So to carry on with the troubleshooting end, if you have a problem with your wiring or your circuit, you're going to need that OEM information and you're going to have to go at it from there with voltage drops. You may end up needing a laptop to see what the engine is seeing and see if the engine is actually turning the fan on. But for the real simple one and the common one, when we get that debris buildup between the charge air cooler and the radiator, what we're going to need to do is clean it out. Now, some trucks are very, very tight at the front. You may have to actually remove your engine fan. You may have to remove the radiator shroud, right, this piece here. Sorry, I'm going to just change the color a little bit. We might have to remove this piece and remove this piece so that we can get in and wash the radiator properly. The best way to do this is to push the debris back where it came from. However, you do have to be really, really careful. Don't try and do this with a pressure washer. Okay? Those pressure washers have got the water coming out at such a speed that you can actually damage the radiator fins. You can fold them right over to the point where you can't even fix it anymore. You're going to need to use a low pressure device of some sort, and I'm going to give you a couple options here that I built. And to give you an idea, before I show you the proper tools, this is what can happen very, very easily from hitting those radiator fins with a pressure washer, especially if you hit them on an angle. Good option right over here, there's two of them for washing out radiators. If you notice on the end here, I've got a 90-degree fitting. Now, you can use air. I built this blowgun with just a piece of copper tubing to back blow it. The other tool that I actually like better for doing this is the one that uses water. Now down here, you just hook up a garden hose, so you're looking at maybe 70 to 90 psi maximum. Nice flexible piece of copper tubing with a 90 on the end, so we can get in. Now this particular truck, we'd have to remove the shroud for sure, but we can get in here and push all that crud back the way it came from, rather than washing it from the front and just pushing it all deeper into the fins. What's the moral of the story? Number one, you need airflow, or we need airflow through that condenser to get the AC to work. Whether it's parked, whether it's driving, we need airflow. Build-up between the charge air cooler and the radiator is a very, very common problem, but it's awfully hard to see. You're going to need to work a little bit to look at it and find it. And if you do have problems with airflow through the condenser, the nice thing is you'll usually get a complaint of your engine running hot, and the troubleshooting becomes a lot easier.